So what we're looking at here is a wall-mounted cabinet that's got a remote radio head built into it, comprising of a LimeSDR together with an Intel Core i5 NUC. The LimeSDR is connected to a PA module and an LNA module. They are in turn connected to a coaxial relay, and then that's finally connected to a wideband roof-mounted antenna which covers 25 MHz to 3 GHz. The Intel NUC is also connected to the local area network. Just to my left-hand side, we have a laptop that has a terminal window open with an SSH session on the Intel NUC. All we need to do to make that LimeSDR board available via the network is to run SoapySDR server. It's incredibly simple. So if we start SoapySDR server on the NUC, now that's available as a network resource, we can go to another terminal window that's actually a local window on this this laptop, which is a Intel Core i7 system. We can run the Osmocom FFT software, but in the driver arguments we specify that we want to use a remote system, which is limesdr.local, and then we want to pass two arguments to the driver on the remote system, which is driver equals lime and soapy equals 0, which is in other words the first SoapySDR device. We also tell the FFT that we want to tune to 100 MHz. So if I start this, and then what I'll do is I'll switch to another tab, which again is on this machine, this local machine here, and we can look at the CPU utilization when the FFT software's started. We can just see in the background actually on the other window, which is the remote SSH session, that SoapySDR server has seen the connection coming in. If we run top on the local machine, we can see that the FFT software is taking up pretty much all of a core, a whole core, and that's using OpenCL for acceleration also, so it's using the SIMD extensions on the Core i7. If we go back to our remote window, we've got another tab open on there, and if we run top on that, we can see how much CPU utilization there is on the Intel NUC, and we can see it's just taking up 30-odd%, 35% or thereabouts, with the SoapySDR server process. Now if we go to our FFT display, we can increase the LNA gain, and we can see here a number of what we can only assume are FM broadcast radio signals. And if we bring this window over here, this is showing graphs being generated by the network switch, and we can see that we've got a healthy around 350 megabits per second of samples being streamed from the Intel NUC across to the laptop. So yeah, so it's as simple as that. There you are.